Okay, so today I am going to solve a problem, rotate array. The problem statement is we are given with an integer array nums and we have to rotate this array to the right by k steps, where k is non-negative. It means we can have to rotate this array by 0 steps or by positive number of steps, any non-zero. So here we are given with an example, two examples with arrays, with a particular array and k value with which we have to rotate this array to the right. So rotating an array by k steps to the right, it is like we have to shift this particular each and every element in this array to the right by k steps. It means if in this particular example, if nums array is this and the k value is given as 3, so we have to we have to basically rotate the array by 3 steps, or we can say we have to shift each and every element in this array by 3 steps. So before going to the final code of this problem, firstly I would like to discuss my approach. Here I will discuss two approaches. One is the basic approach, brute force approach, which we can think of initially, and later on we will go with the optimized approach, optimized code. So here I will take the example 1 to explain it. So here we are solving the rotate array problem, and we are given with this input array whose size is 7 and having these particular elements. Now we have to rotate this array where we are given with k value equal to 3. We are given with k equal to 3. It means we have to rotate this particular array by 3 steps to the right. So basically, if this particular is the element, then we have to shift it to 3 steps ahead to the right. So if it is currently present at 0th index, then it will be moving at 3rd index. If this element is at 1st index, then it will be moving at 4th index. And likewise, if we see this last element, so if we shift this with one step to the right, then firstly it will move to 0th index, then at second step it will move to 1st index, then at third step it will move to 2nd index. This we will see how it will work for the last index, for some of the last indices, if the indices are going out of bound. So firstly, going with the brute force approach, I will discuss the brute force approach. So in the brute force approach, what we can do is that we know that we have to place these every element at the particular index where it is ahead to the 3 steps. Means whatever the current index is, let's say here is 0, so the next index which will be ahead of this with the 3 steps, that will be index 3. When 0 plus 3, it will be 3. If we do this 1 plus 3, it will be 4, so this will be placed at 4. And likewise, every element will be shifted to the 3 steps ahead to the or 3 steps right to it current index. So in this approach, what we are going to do is we are going to take every element and keep it at a particular index which is 3 step ahead. So for this approach, let's say I am having this index 0 for element 1. Now where it will be placed, whatever this element is, it will be placed at the index where it is going from I to I plus 3, means for the 3 steps. So if we are having k, so we can write here k here. Now the problem will come when we will be at the last index. So now how we will keep, if we calculate for this particular index at 6 and we do 6 plus 3, so it is going out of bound. And to solve this particular problem that it should not go out of bound, what we will do, we will keep it this I plus k, and we will wrap around this particular condition with the length of this array or the size of this array. So let's say if we are calculating for this last index, so it will be 6 plus 3. And now when we will do the wraparound here, wraparound means with modulus with this length of this array, means n. The size of this array is 7 simply. So now when this 9 modulus of 7 is going to happen, so what will be the index? It will give us the remainder as 2. So the remainder is 2, so it means whatever the element this is present at this current index, now it will be moving next to the 3 steps ahead, and that index will be second index, which this is giving. So this is the this is how we are going to handle this case of out of bound. Same will happen with the 6. Now when we take this 6, whatever the index it is currently at, so it will be done as 5 plus 3. and this will be 8. Now it is going out of bounds, so we will wrap around it with the length of the array, that is 7. So here what will come? Here 8 modulus 7, so the remainder will come 1. It means that this particular element will be going at 1 index, so here 6 is going. So this is how we are going to do this thing. We are taking a rotated array and we will be keeping every element in that rotated array. Means we are going to take an extra array, that is rotated array. This is the array we will be taking, and taking each and every element, traversing in this original array and taking each and every element and putting it the 3 steps ahead index in this final array, that is rotated array. Now let me tell you the code which I have already written for this approach. So this is the code which I had already written. Now I will explain with the help of this code. So as I am already having these two arrays, so let me copy these two arrays from here. Okay, so we will see step by step how it is going to work. Now this is the function implementation which I have written for this, and I have taken the size of array in this n. Now I have created another array. This is the rotated array which I have created, and in this initially as of now the elements are there, but initially it will be like all the elements will be initialized with 0. Now what we will do is we will whatever the value we are having for k, in order to avoid any problem later on, like the out of bound problem, so in that what we will do, we will just simply take this modulus with n. See, because whatever the value we are given with k, if we are if we have to rotate this particular array by 3 steps, or even if any particular k value is there, let's say that particular value is let's say the value is k value is 10, k equal to 10. Now in that case, if we will have to rotate this array by 10 steps, and the size of array is only 7 here. Okay, so in this what we will do, we will simply take this k value, it means 10 value, and we will mod it with the size of the array, that is 7. So what will come? The remainder will come as 3. So 3 will come, means we will be taking the value this of this 10 as 3, because whatever the result of 3 will come, the same result will come for 10 also, because if we take any value which is of k which is equal to the size of the array, there will be no change in the array. So till 7 there will be no change, and after that 7, those 3 particular shifts we will be making, so those will affect, and simply same thing will happen in the case of k equal to 3. So this is how the things are working. That's why we are taking k mod n, so that it works for every value of n or every value of k, and after that we will be running this for loop from 0 to n minus 1 size, and we will go at every index like this. Let's say at I equal to 0, we will take that element from that index and keep that element where we will go in the rotated array and go at I plus k index there. Let's say I index is 0, and we will go plus k, as we are given with k equal to 3, so we will go 0 plus 3 and then mod it with n. That will be helpful in the case where we are at the last indices. So this is how we are going to work upon that. We will take every index element and we will go in the rotated array 3 steps ahead of that index and keep that element there. So this is how we are going to shift every element by k steps, or in this case k equal to 3 steps. So this is how the things are working, and after that whatever the rotated array we are having, as a result we will simply copy it inside the nums array, and this is how we are going to rotate this array by k steps, or shift the elements, every element by 3 steps. So this is the simple approach. So but see, if we see the time complexity of this approach, so time complexity is simple, that it is taking big O of n time complexity only. But if we see the space complexity, so the space complexity is basically n, because we are using the extra array, that is rotated array, which is of size n. So the complexity, space complexity, if it is we are using in this case, this is not, it is not an efficient approach. In order to go with the better approach, we can think of something in which we do not have to use an extra array. So let's go inside the another approach, and this I will call as optimized approach, or better approach, I can say. Okay, so this is the approach which we are going to use. Now I have taken the array which is the original array as an example, which is given in the problem, And now what we will do is, what we can think of, that yes, we have to rotate this particular array by k steps, or we have to shift the elements by k steps to the right. So if we see the in the problem, that what is the result coming out, result is coming something like this. It means this 5 6 7 are placed here, and this 1 2 3 4 are going at the end. It means firstly 7 will be going here, then 6 will be going here, then 5 will be going here. And this is how we can say that this elements are somewhat shifted in this way, that uh, uh, at one step it is going here, then at second step it will be moving here, and then third step it will be moving at the another index. So likewise 3 steps are there for every element. So if we see the given array, that is the original array, and the final array as an output, so if we see that these elements are coming here, these are coming here, so what I have analyzed is that if we can reverse this first part, whatever this first part is given to us, this is the part we are given with, we can firstly reverse this, so it will look something like this: 4 3 2 1. And then whatever this part is there, we can reverse this part. So after reversing, it will look something like this, that 7 comes here, 6 comes here, 5 comes here. So this is how it is working. And after, when we have this entire part, this firstly we have reversed this, then we have reversed this. So how it will look like, it will look something like this. And later on, what we can do is, we can simply take this array and then reverse it as whole. So firstly what we did is, we firstly reverse this part, then we reverse this part, and after getting this entire result, we will simply reverse it all, so that we can get the our output as a final result, what is the desired result which we want. Firstly, what I am going to do here, firstly I will reverse from where to where. Firstly, see, I will go at in nums array, I will take this nums array simply, and in this nums array I will go at 0th index, and then I will go from here to here, from 0 to 3rd index. I will reverse this, then I will perform this another reverse function, where I will take this nums array, and then I will go from this 4th index till last index, that is 6th. And then after, what I am doing, I am simply taking this nums array, and I am going at 0th index until n-1, whatever is the size, that is 6 here. So I am then reversing this entire array. So I am doing it in 3 steps. Firstly, I am reversing first part, then I am reversing another part, and then I am reversing the whole, array as a whole. So now we can also let's try to generalize this, that how it is going to work now. So what I can do here is that I will implement a I will implement this reverse function, and here what I will do is, I will take this nums array. Now see, I have to start from the 0th index, so that is 0 here. Now what I can do, see, I have been given with k equal to 3. I've been given with k equal to 3. So what I can do here is, I can simply can I do this, that I can reverse this from firstly this part from 0 to k, as this k is given as 3, and then from k plus 1 to last. No, we cannot do like that, because if we see the second example, so let's take this example, that's 0 index, 1 index, 2 index, 3 index, and if I try to see this k equal to 2, then I'm going to reverse this from 0 to 2, it means till this index, and that is not what I have to do, and it will not work. So I will have to see for some other analysis, how I can make it generalized. So now what I am having here is that I am having the size of this array, so I can simply take the size of this array, and this is the 7, and then I can take this k value, that is -3. Now it became 4. I have to reverse till 3, so I can make it -1. So how it is going to look like, n minus k minus 1. So I am going to reverse it till 0 to n minus k minus 1. I will write here n minus k minus 1. Till here I will reverse. Now I will write another reverse function in order to reverse the second part, and that will be as I had done till here, that is n minus k minus 1. So plus 1 index will be n minus k. So simply I will start from n minus k, then reverse till n minus 1, that is the end index of the array. And now this is the simple thing, that I can take this nums array, and I can start from 0th index and then go till n minus 1. So these are the simple 3 three particular steps which we have to follow to get the desired result. Now let's get to the code part where we can write this code. So this is the code editor where firstly I will take the size of this array, that is nums.size in n. I have taken the size of this array in n. Now what I have to do, I have to simply reverse this particular parts. So firstly I will write a function. Firstly I will call a function that is reverse array, and here I will give this nums array as an argument, and then I can take the 0th index. I can give the 0th index, and then till I will go till n minus k minus 1. Another function I will call is for reverse array for the another part, that is I will give the nums array here. I will go from n minus k till n minus 1, and then after again I will call one reverse array function where I will give the nums array, and starting from 0th index till n minus 1 completely reverse this array. So this is the thing. Now I will have to write this implementation for this reverse function. Okay, so here I will write this void implementation reverse array. Inside this, firstly I will have to give this nums array vector int, and I will pass this particular array by reference because I have to make changes in this whatever the array we are given with. We have to make this changes in this array, and then I will take a start value for this first index from where we have to start to reverse, and then secondly I will in the third parameter I will take the end index till where I have to reverse, starting from where I have to reverse until where I have to reverse. For that I will take these two pointers to point here. Now firstly I will store this start in s, and then I will store this end in another variable. So these are the two pointers. Now I have to simply reverse this array. So what is the simple simple approach that how we reverse a particular array? We simply take two pointers at first and then at last, and we try to and we just swap those elements. So what how we will do is we will run this while loop, and this particular while loop will be running till s is not equal to n. This s is it will be running till s is less than or equal to n. It means whenever this particular s will cross e, when both of these pointers will cross, this particular loop will be ended. Here what I have to do is I simply have to swap these nums of s comma nums of end, whatever these elements are there. You simply have to swap these, and then just increment this start pointer and then decrement this end pointer, and this is how our array will get reversed. So this is the simple thing, that firstly we will run this to reverse the first part, and then secondly to reverse the second part, and then third to reverse the entire array, and which will give us the final result, as in this case this is the output. Now one more thing is we can write one some of we can think of that if any particular array is only of size 1, so in that case we need not to reverse this reverse any particular part. So if I can write a condition that if n is less than or equal to 1, it means the size is 1, or let's say it is 0, so in that case we need not to do anything. We can simply return like this. Okay, so this will be the approach. Now let me firstly run this code. Okay, so got accepted, and let me submit it first. Okay, so what's the problem coming here? It is in the runtime. Okay, so if the array size is 2, if the array size is 2, yes, the problem here is that if we have found that if this array size is 1 or less, then in that case we do not have any problem. We can simply return from here. But if it is not the case, if the particular size of array is 2 or greater, then in that case, the thing which we did in this particular case, that we have firstly took this k value, whatever the k value we are given with, we will have to take the mod of n and keep it inside k, so that it works for every case. So we will take this k value with k mod n. We will firstly take the k mod n, and then we will save it inside k, and that k we will be using then. So this is the thing which we are missing here. Okay. Let me run this and then again submit it. Okay, so now it got accepted. Now let's see the time complexity here. So see, we are not using any extra space here because we are only using this particular approach in order to avoid that space which we are using in brute force approach. So we do not have any extra array we have used here. The time complexity we see, so we have used this three particular steps for the reverse. So in every step, if we see when we are reversing this array, so we are using like n by 2 steps in every reverse operation, like in the first, second, and then whole part. So n by 2 sorry, swap operations are used. Swap operations are like, if we see for the first reverse function, so they are equal to n by 2 only, and if we see for the second, so n by 2 itself, then for third, so n by 2 again, we are swapping the elements. So like the number of swaps are n by 2, and it will be 3n by 2. If we see, then yes, big O of n time only we are taking. This is the simple time complexity, and yes, the time complexity we use, that is big O of n, and the space complexity not using any extra space, so it is constant only. This is how we have solved this problem with the brute force, and then gone to the optimal approach. That's all about this problem.